What up? And welcome back to the third part of the Easter special of coding Snake in x86 assembly. And the last time we made the snake move, the next step obviously is to control the snake. So that's what we're going to do today. Before we're going to do that, we're going to correct three little things. The first thing that we're going to correct, first of all, we are checking if everything is still running. So our snake's still moving. That seems to be fine. But the first thing I want to correct is, if you remember, the last time we added a head. And I'm going to comment this out, but I'm going to clear the screen and just print the playing field. So we have the initialized snake. And if we look at that, we have just 4 pieces here without a head. So we're going to correct for that now. We're going to go here to the initialize snake function. And we have here the loop. And if you remember, we just took the playing field and added the 4 pieces in the loop. And this is what we are doing right about here. So let me grab that line, put it here. And now instead of putting the symbol there, I'm going to place the head symbol here. And let's compile this. Now notice we have 4 pieces, and that places the head here appends the head. That's because in the loop we increased RDE. So we're going to be pretty crude here now and just at the end subtract 1 again, and that should give us a 4-piece initialization. So that was the one thing I wanted to correct. Then here the direction is an int. That's not really necessary, so I'm going to change that to a byte. It's just a value between 1 and 4, so it's a little bit of an overkill. However, we have to be careful here when we store the 1 in the direction. We have to now use the byte, and I'm not sure if we use this anymore else here. Here we move the direction into RAX. Here we're going to also use the byte. Now byte low, what was that? R low. And then I have to here change the comparison function, compare byte to R low. So let me do this here. Did I R low, and Q gets a byte. Gotta do this slowly here. So this still works. Well, we're not moving because we commented that part out. So let's get back to this part. This seems to work, but let's be sure. Let's change the direction to 3. And that also works. Now we're going to actually do one more thing. At the end of the last video, I rushed a little bit towards the else if statements there. So let's go to move snake. That's right here. And to the direction. So this here, what we're doing here is pretty crude. We're looking, is the direction a 1? If it is, we jump. If it isn't, then we're going to go check if it's 2. If it's not a 2, then we're going to check if it's a 3. And if it's not a 3, we're going to check if it's a 4. And if we are thorough, we should always at the end here at least jump to end directions. I didn't even see that I forgot that. See, we're going to add this, because once we have the direction, it's not another one. And like I said, what you really should do here is a switch statement, and at the end of this video we're going to do that. So and for that reason also, we're going to change the numbers of the directions now. So I might have not mentioned that, but up until this point, let me do this a little there and put this back. Up until now, the direction in front, that was my 1 because it was always the default. On the back here was the 2. Here I placed the 3, and here I placed the 4. We're going to change that now. We're going to change it as follows. Forward is going to be a 3. Backwards is going to be a 4. Up is going to be a 1. And down is going to be a 2. And it will become apparent in a moment why we do that. But first, let us do that. So this here is the forwards movement. So this is now 3. This here is the backwards movement. This is now a 4. This is the up movement is now a 1. And down is now going to be a 2. So now we're moving forward. That's good. But let's check all of the directions. So here, when we initialize it, if I replace it with a 1, it should go up. That's okay. If I replace this with a 2, it should go down. It goes down. It goes down, and 4 should go backwards or to the left. And also that works. So let's replace it with 3 and go forward. So these are the changes that I wanted to do. 1 second, and a little bit of liquid. And now we have to control the snake. How are we going to do that? Well, with a function. Well, actually, all we have to do really is the control function. Now we're going to write this. Let's go here and let's say control snake. And then we're going to have an end control snake. We now have to push Q, RBP. I'm going to move the stack pointer in the base pointer. This is not the base pointer. And here we're going to do it the other way around. I'm going to pop Q and return. So if you think about it, we have a direction. All we have to do is get the input from the keyboard and then update the direction flag in memory. And the move snake function will grab that byte and based on that change the direction of the snake. So how do we grab the input key? That's done with the read function. The same way we can use write to standard out. We can use sysread for reading from standard in. So the first thing we need though is a place where we're going to write that, and that's going to be right about here. I'm going to call this input key. It's going to be an ASCII character. I'm not sure how much I want at the moment, so let's say at first we're going to start with 4 characters. I'm just going to place Z. Z's there, Z's there, Z's there, whatever. This letter, that's going to have it. We have the input key, and then we're going to go and layer Q that. Q input key rip into a register. Which register? I have no idea. So let us check that. I have written this down. You can check it on the GitHub as well, but I have this open. Nope. I want this. Why does it open this in this format? Nobody knows. ARM. No, we're not. We're on x86. To upper this. Oh, come on, man. Why are you opening all of this? Okay. README. Get rid of this. And we have here somewhere the syscall. So this is, I'll make this a little bit smaller, yeah. So this is the read syscall. I should put this down here. This is the read syscall. So it's this number, our 5 zeros and a 3. The file descriptor is a standard in now, and the buffer location is our input key. And the buffer size is how many bytes we want to read. So, having said that, let's first, GG, oh, we can leave GG there. So, first of all, we're going to say sysread, which is 0x212345, and I forgot already, 3. And then 3 is before 5, 4. Okay, so we have sysread. Then we need the file descriptor is going to be standard in. Do we have this here? EQ std in, and std in is 0. And 0 is before 1. So now we're going to go to GG and look where we need our buffer location. The buffer location has to be in RSE. So let's place this address in RSE. Now in RAX has to be the syscall, so let's move Q $sys read into RAX. Sys in RX, RDE has the file descriptor standard in, so move Q std in into %RDE, and the buffer location is in RSE. We already did that. And the buffer size, so the buffer size is at the moment 4 into RDX. Is RDX? Yes. Oops. So 4 because I placed 4 ASCII characters right about here. So this should be that, and now we're going to do a syscall. And the syscall will now, if it works correctly, place whatever we input, 4 bytes that we input into the buffer location that we gave it, and that's in our case input key. Is there the last E here cannot be capitalized, so let's do that, and let's call control snake in our loop. Oh, snake, write it and test it, and while nothing happens, I press forward, enter, I press G, enter, and it just moves forward. But now it blocks the input and waits for every input key. However, YSD, let's check if the syscall is actually working. So we're gonna go here to control snake, and now we have construction going on. LLDB snake, break set minus address this. Him twice. Okay, so now we have the input key in register read RSE. So let's see what it is. This is the location. So we're going to go check that out. So here are our four Z characters, and here's the starting direction, which is now forward and 3. Beautifully done. So let's see if the syscall works. So now I'm going to go the syscall, and I'm going to press J, which is down in Vim things. And that was the syscall. So now we're going to check out the memory again, and as you can see, here's our 0x6a, and that's the ASCII character for the lowercase j. So that's pretty good, but let's run it again. And now I'm going to press, it's the syscall, and I'm going to press the right key. And we're going to check out the memory again. And now we can see that here is 0x1b, that's the escape character. Then we have a 0x5b and a 0x43. And the 0x43 is actually the right key, or the code for the right key. And now you can also see why I updated the addresses, because the key values are 41, 42, 43, and 44, and they all correspond to, in the last digit, to these 4 directions. And we're gonna use that property. So that's why I had to update that, or wanted to update that. And we're gonna go in and gonna get the 43 now, and based on the 43, update the direction in memory. At first, we're gonna do this rather crude. Then we're gonna get the terminal into raw mode, or non-blocking input mode, and after that, we're gonna refine the control function. That's the plan. So, without further ado, what do we have to actually do? Well, as of now, we have something in input key. So if we get that value into a register, this is move byte, let's say move byte, this is 0. So for the first part now, I'm going to assume that I only press input keys, and so the only inputs we have are one of the 4 input keys. So that means for us that 0, 1, 2 of an offset from the input key address will be a number that will be the number that we want. So we're going to use, I said it, but I don't remember, 0, 1, 2. We're going to move 2 of, no, can we do this? 1 second. We have to do input key, rip. So this would be this address, and then we could do, I haven't done this. This should work though, I think, in allo. In allo. So let's do that. Let's see if that is an, no, it's an address, or it's an opcode. So let's check that though. Object dump minus the snake. Where are we in the control snake now? LLDB, reset. Okay, Chris Lettner and his always ask me twice. So this call I'm gonna press down, which should be 42. So we're gonna move this now. Register read allo is 4 now, and now we have the 42 in allo. All right. 42 is fine, but we have to really need the 40. So we're gonna go subtract 0x40 from allo. We could do that, but we won't do that. Not yet. We will do that later. Now, because now we're going to compare to the keys. So we're going to make here control forward label. I'm gonna compare Q, compare byte, 0x forward is 43 with low, and say jump not equal to control backwards. And then I'm gonna copy this, place this label here, copy this. So the idea is now to go all through all the 4 directions as well. So this is control. Here we check if it's control backwards. If it's not control backwards, we're going to control up. Okay, control up. Control backwards needs also a colon. Gonna copy this. This is now control up is 41, and finally we have here control down, and this has also to be a down, and down is 42, and then we're going to place here and controls. Now, okay, no, I was like confusing myself there. Okay, so we have end controls here. Controls. So this is okay. So all we do right now is we get the key. We assume again that it is one of the 4 arrow keys. And then we compare it with 43. If it's not 43, we're going to compare it with 44, then with 41, then with 42, and so on. Well, actually, no so on. By 42, we're at the end. However, we are not doing anything yet. Let's assume it is 43. That means we have to move byte. The number forward is 3. We could now, I mean, we can use the immediate right now, but we're not, well, I don't want to do that, but for reasons that will only be clear at the end. I'm going to subbyte 0x40 from %low. So now we have in low also a 3, and then we're gonna move byte low into direction rip. So this should be this. Oops, we are in LLDB. Invalid instruction mnemonic. You wanted to say, actually, where were we? Control down. Control down. I think you wanted to say, put a colon there. And there you wanted to say 357. Don't forget the comma. Not supported. Relog length in section text. What are you talking about? This is all text section. So wait, what does he not want? Relocation.
Yeah, you can see the
This is all in data. What? Where is he complaining now? Was that here? No. When was the? Oops, this is not commenting out. 1 second. So the okay. Sub. Is this here direction? This is not working. Move. Okay. Yeah, it's not working because that's not a percent sign. All right. Couldn't I have said so? Okay, so now, nevertheless, here in this we could still use. So let's use here this. Go here and the same thing I forgot last time apparently. So not branch, jump to end controls, right? So now we would do always the same here, and instead of that it's the same here is the special part. Why we are not doing this? We could say if it's a 2, then just move Q or move by $2 into direction at rip, right? That would be the same, would have the same result here. So let's. Here, can I now do anything? See, now I can press the up key and it moves up. I can press the right key to be fast so you can maybe see something. Now I press the up key again. Now it goes up. Now press the right key and it goes right. Now press the left key and we are going left. Down again. And we're pressing down. And one more time right. And here goes nothing. So this is working. So again, these 3 lines are not necessary. The only special part here is that we are actually using the last digit of the input keys. So let me make this here uniform. Put this here as well, so this should also be fine. And this end controls here, we obviously don't need. All right. So we have the snake moving, but we have a problem with the terminal. And now we're going to have to kick or enable the raw mode. And the way that works is, well, I'm going to write a function enable raw mode. That's the basic thing that we're going to do. But yeah. So let's do that first. Let's call it and then write it. Okay. Enough stuff. All right. Enable raw mode. Can I hit this? Thank you. Nud. I'm so annoyed that this is not counting as an end of a word. Push Q RBP. Move Q RSP into RBP. And at the end here, change this, restore the stack pointer, and then pop Q RBP and return. All right. So what are we actually doing now? The terminal is controlled by two functions. So this, or the whole terminal is controlled by something known as termios. I had this big, I thought. How's that? Okay, is this big enough? Two more. So if you go in the man page, it's termios.h. Termios stands for Terminal Input Output System, not man termios. Termios, like this. Okay, this is the termios system, and this is what has some ancient history, I don't know. But this is what's normally used for the terminal, and has every Linux system has this, and macOS has this as well. And this has a configuration for how the terminal reacts. And in normal mode, canonical mode, or cooked mode, it blocks the input. That means you enter the number. If we go back here to our snake, if I press forward, you see that there's the character printed, and now I have to confirm it with enter. I have to press down, there's something printed, and then I have to confirm it. These two things are controlled by two flags in the terminal. The one is echo, this is the one that prints out the character, and the other one is called ICANON. And that is always turned on in cooked mode, and says if you enter something, you always have to confirm it with enter before we read in your input. And the goal is now to turn this off. And this is done with one function, or with two functions. They are called tcgetattr and tcsetAttributes. Basically, all that is happening is we're gonna call tcgetattr, load in the current configuration. Yeah, it's like a configuration struct of the terminal. Then we're going to modify that struct, and after we've modified it, we're going to call tcsetAttribute and give the terminal our modified struct, and it's going to then adjust the input output accordingly. So that's the external functions that we need. Yeah, that's really what we want to do. I have here, I download this. If you go search on your Mac, you will find, you're not calling Xcode on me for scope. You open this. This is a file that should be you find on your Mac, and we can look up a few flags here. So if you go to termios, this is, for example, the termios struct that we are going to modify. And then we have the ICANON that I mentioned here. This has actual numbers. And let me also make this bigger and put this to the side here. So you see that ICANON is mentioned here. And this has also somewhere a value. This is exactly this one. And the echo flag has this value. And I also wrote this all down somewhere. Do I have this open recent? Here. So on the GitHub you will find this, what the flags actually are. Right about here. These are the ones that we are going to need. But I think we're going to use the terminal file here, because this is more instructive. The numbers are not magic. They're not coming from the sky. So let's go back here. And the first thing we want to do is call tcgetattr. So let's go here, man tcgetattr, and somewhere here is the function, right about here. So we have two arguments. One is the struct, and the other one is an int called fields, and that fields number is normally standard in file number. This is a POSIX thing, and it's just 1. So, having said all of that again, the first thing we're going to do is create our terminal or our terminus struct. So terminus raw, and I know it now because I just did it, but let's pretend we don't know how big it is. So we're gonna fill memory with the size of guest fetty. They are all 1 by 1, and I'm placing a 1 there. And then we're gonna do the same for another one, which we call cooked, and there I'm gonna place the value 2. All right, and now in our enable raw mode function, we're gonna take the memory of the cooked one. So we're gonna layer Q terminus cooked, rip into the, I don't even know, well, we do know more or less. This should be normal function convention. Where is my thing? So this is the tcget, this is RDE, and this will be RSE. So we're gonna place this in RSE, and then we're gonna place the value 1 into RDE. I'm gonna do that this way, so we are in the right order. And now, but we could check that first, and then we're gonna have to call the function. So enable raw mode. So we're going to go right about somewhere here. Let's call enable raw mode. Let's compile it. It doesn't like the comma. I'm fine with that. I'm gonna remove it here. And it's running. And is it crashing? Well, it's not crashing. That's always good. So object, let's investigate. Snackek. Snackek is nothing. We're gonna go here into enable raw mode. LLDP. But I can set at the address. And we're going to go here. So now we have register read RSE. This here is the cooked. Didn't we have the raw one? Where am I? Cooked. Oh, I took the cooked. I didn't want to do that. So let me change that. I wanted to have the raw one. So let's compile it and go here again. And now we have here the raw one. So here's the raw struct or the raw memory. Let's 128 check it out. And here we wrote 1s and 0s in memory. And now we're going to call tcgetattr. So what we want to do, we have everything set up. We want to call tcgetattr. And that's obviously not going to work like that, right? Because now we are not anymore having a static library or static executable. We have to link it against libc, and on macOS, libc is part of libsystem. So we have to link against libsystem. So the best way to do that is to look at xcrown and look for what is here, the show the SDK path. So we can go xcrown, show SDK path, and you will get your SDK part. So let's copy this here and go in our makefile. And now we're gonna go into include or we're going to define include, and I'm going to copy paste this here and put these ticks around it. So this will, well, did I have this here? This gives us the SDK part, but not the path to the libraries. What we need though is the path to the libraries. So what, to get the library part, there is a command called syslib root. And then finally we want L system is what we're going to link against. So this is that. So here we're going to just include this now for the linker. And he wants $. And this should be fine, but let's check if it compiles now. No, it does not. Not found. Ignoring unexpected blib text stub file. So something is not correct. System syslib root. This is, oh, well, let's remove static here, and that works because obviously I cannot have it static and linked against it. Okay, that is a thing. So let's call the function. Does it do anything? Okay, that is so far so nothing, because we don't know if anything happened. We just know it didn't crash. So where are we? Why are we? Here we're going into, no, we're going into not control snakes, we're going into enable raw mode again. VB. Break. No, that's not correct. We want to break now here. So here we are. And now we're going to call the function. So before we do that, let's go, that's not register read RSE. Terminus raw is now here. Still there is no 1. Am I in a completely different park? Well, let's check it out. Copy x128xp. Yeah. Okay, these are the ones and zeros. So frame select. Now we're gonna jump over the function of tcget. So break set here. I'm gonna continue. So now it was called, and let's see, and voila, we have something. So all of this here is the struct from the terminal function, or tcget, what is it called? tcgetattr attributes, tcget attributes. And as you can see here, we have too much from our memory, and that's because our struct is smaller than the 50 that we set aside. It's actually 48. So we can now change that. So here I'm going to place space 0x48. Okay, so now we loaded the terminus struct into memory. The next thing is we're going to have to modify it and then send it back to the terminal to get our updated memory or our updated terminal setting. Before we do that, we will have to update the current configuration in the cooked terminal struct. This is the whole premise, is leave no trace. We're going to change the terminal. Once we leave our program, we're going to restore the terminal to in the same state we found it. So what we're going to need is a very simple struct copy function. And this is really a rudimentary one. This is nothing fancy. We're going to do a byte by byte copy. So let's write copy struct and copy struct push q rdp move q rsp into rdp. I have to blink 1 second here. I'll check the camera as well. I'm in the dark night and sunny Gotham City behind me. We good here. We good here. We have to take a little look here on this battery again. Okay, RSP to RBP and RBP to RSP. We're gonna pop Q RBP and we're gonna return. Okay, so we're going to use the standard function convention. So RDE is going to have the source address. RSE is going to have target address. And RDX is going to have the amount of bytes. So let me put this here. So we need obviously a loop counter, RSE, though let's use RDX. 0 goes into RAX. We need a loop. Copy struct loop. And then we need an end to that. And then we're going to compare RAX with where are the bytes in RDX. We're going to be in RDX. And, well, then we're going to, if they are equal, jump equal. This or this, jump equal. And we're going to jump to end. Copy struct loop. Otherwise, like I said, we're gonna make this super simple. We're gonna the oldest part of the architecture, load ALU store. Actually, now we're just doing load and store. All right, we're gonna load 1 byte, move byte from wherever the source is RDE, RSE, and it's going to be exactly 1 byte into let's do RCX. RBX is volatile. So, and then we're going to take that what is in RCX and move it back to RDE. No, RSE, RERSE, that's not correct here. This has to be the loop counter, RAX. So we have to RSE, we're going to take the loop counter, RAX, and we're going to scale it by 1. So now this is going to move, so this instruction is going to take 1 byte, move it into RCX, and then we can take it from RCX and move it back into memory where the target address is. And then all that remains is adding increment we have here. We're increment Q RAX, and then we're gonna jump to copy struct loop. And this should actually be all. It's never gonna work, but it should be all. Where are we? Invalid operand. Yeah, that's correct. We said something right. move byte RDE into obviously C low, and then we're gonna use here C low and move it into memory. Space needs a dot, so we're gonna give it a dot, and why does this take so long? A little bit of sun is coming out. Okay, no, it's not coming out. It's coming out behind the building. Where are we? Control snake. No, where am I? Like, get a little bit of sun and lose all focus. So enable raw mode. We have our terminal struct now in the raw struct, and now we're gonna copy it. So we're gonna load the address layer Q terminus raw into rip, not into rip, terminus raw rip into RDE is the source. Then we're gonna take the cooked mode, cooked into our SE, and the byte number is still 0x48, and that goes into RDX. So now we're gonna call copy struct and hope it doesn't crash. Where am I? Here's our program, and here we want to test it. First we test if it doesn't crash, Object dump minus the snake. We're gonna take the battery. The battery is draining. We have to probably do this in two. I have to have a charging moment here today. So where is, well, enable raw mode. That's where we want to go. So let's go here. LLDB snake break set minus address right about here. Do it again. Do it again. And where am I? There. Okay, we are in the thing. Gonna also go here. Break set minus address. Ranga. We're gonna continue. Let's check out the memory. So here's our struct is there, and here are our tools. And now we are going to check. I'm going to jump confidently over this. So break set this address here. So now it was executed. So let's see how it did. Where is my X there? Well, it copied something. Here's now before we had all the twos, now we have 8025 is here, and now here starts the cooked struct. Add 5b, and we need a little bit more, so let's take whatever, 68, I don't know. So this is the first struct. And now we have to see if everything is here. Here is the second struct. And we have the 2 line, so we are actually good. We have copied exactly the 48 bytes. And that looks good. So we backed up our terminal. Now let's just change that to stuff here with space 0x48. So we have this as well. So now we have our struct, we have it backed up to restore the terminal later. Now what we're going to do is actually change it. So where are we? Why are we? What are we doing? How do we change it? We need, like I said, the first 2 things that we're going to change is the echo flag, so we don't get the output from when we press a key, and then the ICANON flag, ICANONIC, which makes sure that we don't have to confirm with enter. I don't know what we have. So let's first load again what actually do we want? The terminus raw. And now we have it raw rip in. Let's put it in RDX. It's a little optimistic, but maybe it helps. So these are the two flags that we have to change, ICANON and echo. So we can just copy them probably. So where are we? Let's move Q 0x into RAX. And where was the other one? This is echo and ICANON in RCX into RCX, and then let's write here actually what these flags are. This is echo, and this here is ICANON. Okay, so now what we need to do is, the way this works is terminus ICANON. No, not, yeah, well, that's okay. ICANON here is part of the L flags. So we have to get the L flag, that's a bunch of ones and zeros, and certain bits are responsible for certain actions in the terminal, and the flags ICANON and echo say, if we are turning them off, it says don't echo out the characters and don't ask for the return character. So that's the whole idea now. And then we're gonna notice that these are 8 bytes long. So this starts at 8, this starts at 16, and this starts at 24. Yeah, that's right, I think. Okay. A little bit, we have the address of the struct, but we need the actually the can we do this? Well, I just said 24, right? Let's try that. So this is 0 to 8, so this starts at 8, this starts at 16, and this starts at 24. So we should have now the L flag in RDX. RAX, RCX. Now what we have to do is order RAX, RCX, and RAX. So we are using both, and I'm going to write the C terminology here in case you know that. It's echo or ICANON. And up until now they are on, but we want to turn them off, so we're gonna not this, not RAX. So could have copied that. I should have copied that. So let's do this. This should be now not these two flags in RAX. Not, and now we have to end that with the RDX register. So and RAX with RDX. Did I forget anything? So this is typically and equals this part. Okay, so now we have this in the RDX register, but we have to move Q RDX into our struct here, terminus raw plus 24. I'm not very optimistic here in what I'm doing. Into this. And I think it's time to ask LLDB. Is this correct there? Is this correct? Okay, LLDB consultation. Object dump. Where are we? Right about here. Address stayed the same. Break. Well, this address stayed the same. Bad execution. Okay. Enable raw mode. Yeah, tell us when. So let's go here. Break set. Continue. Let's check our memory. Oh, we have not copied it yet, but it's still there. Go here, break set, continue here. We're going to check the memory. The copying, all of that is fine. So what are we doing now? Okay, register read RDX. This is terminus raw plus 24. This looks correct. Now we have register read RAX. Register read RAX 48. That is not correct. Why is it 48? Not just 8. Okay, wait. What is register? Oh, we're not there yet. I didn't execute yet. Bad execution. How can it be a bad execution at this point? RX could make this a little more readable. Okay, we forgot the $sign. Well, I can also leave it with the zeros because that was the copied value. But obviously the leading zeros don't matter. So let's do that. LLDB break. I think the other breakpoint. Whoa, the sun is burning here. Okay, let's just run it and still bad execution. Break. Where's our this one? We're gonna start. Did we even compile? Yeah. Okay. So we are in here. Do this again. Break set in this address. Continue. Step. Call the copy. Gonna go here. Break set in this address here. Continue. Where are we? Okay. Now register with RA. Now. We haven't copied yet. Okay. Break set his address here. Continue. X. The struct. This is not struct. Something is wrong here. The struct is not copied now. I don't see where the continue. So this is fine. IE terminus raw RDX, register read RDX, 48, register read RSE, register read RDE is raw, and now we're gonna wanna jump here. Break set as address here, continue, and there's the bad access in our copy function now. Copy struct, or is it this instruction? Did we mess here something up? Well, let's take out this instruction for the moment, because that's the suspicious one. Where's the breakpoint? Okay, we're here. Register read RAX, RSE, terminus cook, register read. Where am I? Register read RAX. That's struct loop. But something is in our struct loop. Copy struct. RDE RSE copy struct. So did we, but this is all afterwards. Compare RAX, C low. I'm gonna do this here real fast. RAX, and the same with RCX. This should not be an issue. LLDB snake, break, R. We're gonna figure this out in a moment. Oh no, we want to out of this place. Okay, raw. And we're gonna copy, break, set as address this, continue. X. Now it copied the struct at least. Okay. Was there something in? I don't know why though. Okay, then we're gonna do this now. Register read RAX. There's our 8. Register read RCX. Here's our whatever that is. 8. This is the real 8. Now we're gonna go register read RAX, or them. That's correct. We're gonna not them. Also correct. Register with RDX. Something 40. Okay. And now we're gonna register with RDX. Update that in the struct. Do we have the struct address still? So here is the 40. Doesn't look quite right, but I don't know this off the top of my head. But there's the 40. Here's the 4B. I think this number is not correct, but why? Obviously, don't remember it exactly. raw mode. Let me check this here. Not and the flag. Oh, that's not correct alone because we didn't do this. Make LLDB snake, Control L, break, run it. Are we gonna do this? Break, continue, and we're back in the function. I wish I had a mouse. There it is. Break set minus address here. We're going to continue. Check the memory. This is still working. Our repaired copy function. Going to go here. Break set minus address here. Continue. Did we do it? At least we copied it. So register with RDX. Tell me is raw plus 24. That's not correct. 32B, yeah, that's not correct. My bad. We have to get the value. We want the flag. We don't want the address of the flag. So let's correct that. Is this? Can we go here? I wish it wouldn't ask me always twice. Oh, but we are at the right position. So register read RDX. That now is the value at the struct. If we look at the struct, this is this flag. Now we have this value, and that's the wherever the terminal thing is. This is now this flag. Like super fast. This flag is now in our RDX register. Frame select, and now we're gonna move the 8 and the. I'll just say 8. Register read the echo flag and the ICANON flag. We're gonna OR them. I think they're in RAX. We're gonna OR them. We're gonna NOT them, and now we're gonna AND them into RDX. Now we have a value, and now we're gonna store this value at this position. So Shivungi, and let's check 04C3, and it was FF here CB05. So that's the updated flag, and hopefully that is what's working. Okay, so we have that, and now we got the struct, we changed the struct, and now we're going to update the struct, where we have updated the struct. But yeah, so let's go man tcgetattr. Let me check the camera 1 second. Okay, we're good. We seem to be good, so we are now going to use the only thing where we're not good is this here, tcgetattr, which is here. I think this is better without the blue. So input fields is again standard input number, std file number, std in file number. This is a 1. This is the terminal struct, the address, and this is here address, and this is the additional option. This is something like tcs flush and tcs now. tcs flush, tcs now. I don't know, vim, no, man, termios. You can go tcs flush, tc, maybe I'm wrong, so flush number, vim, man, tc set attributes. We looked this up, right? Flush. Yeah, that's our. These are the change occurs immediately. The change occurs after all output is written to fields, has been transmitted to the terminal. I don't know. That's what we're going to use. This is value 2. And now looking at it, I would guess this is 0, 1, 2. So let's just do that. And again, where's our function? tc set attributes, RDE, RSE, RSE, RDX. Okay, so move Q R1 into RDE, 2 into RSE, and the address. Layer Q, terminus, what is it called? Termius, raw, rip. I'll be burned tomorrow here. Rip into RDX. And then we're going to call tc set attributes. Make. Oh, we didn't crash. Snake. Look, now I just pressed forward and the snake moves, and I just press up and the snake moves. No echo and no enter return. I can go down, and we made progress. Okay, so far so good. And now we have the last step is to change the vmin and the v time. And do I have still the man pages open here? Man, termios, vmin, is this the thing here? Oh, it's just POSIX has no special meaning for the vmin and vtime entries of the CC. Okay, it has no special meaning. Thank you. The v1 is for how short how long the function waits. The syscall input waits. It's like in 1/10 of a second or something like that. So 1 means 1/10 of a second, and vmin means what's the minimum time to wait. And we're going to set both to 0, so we are not waiting, and the minimum. So no waiting time, and the minimum waiting time is also 0. The minimum is, I think, how many bytes you have to receive before waiting. So let's go back here. You'll see the struct here. This is the struct that we're going to end now, change, and that's at an offset of 32. And vmin and vtime are 16 and 17. So that's also no magic, just it's written right here. If you look here, this is in the CC array. I might have even shown this, right? 16 and 17. So without further ado, let's actually do that. We're gonna do same thing. We're gonna load and now it's again too hot. Termius raw plus 32 rip into RDX, and that's the beginning of the struct. That's the beginning of the, and now we just have to load, or we update, we can just move byte into 16 from RDX. I need a comma here and in this 17 as well. And this is before, no, we didn't do this. We have to do this obviously before we update the struct. So let's test that. And I can move the snake. I'm still surprised because this is not. Okay, we can change directions. I can go up and down, but I can now move with the keyboard. And the reason I'm surprised is that normally with the vmin this should not work that easily. But okay, we have it working. Let me do something that I forgot on the ARM thing. Let us copy all of this, go here, and call this and enable cooked mode. Cooked mode, and here we're gonna start a new function called enable cooked mode. We're gonna do our function stuff, push Q RBP and move Q RSP into RBP. And then we have here terminus raw, we're gonna use terminus cooked. So this should be done everything to restore the terminal to cooked mode. So we are in raw mode. Let's take this function and go raw and call enable raw mode, enable cooked mode. So these should negate each other. So now we should have, yeah, we are again in raw mode, in cooked mode. And if I turn this off, then we are back in raw mode. And this is not for here, this is obviously at the end. However, still, till we are not exiting, I always press Control Z now. So we are exiting not on the real control path. But okay, that's for later. So we have that. And now we're going to do the control snake part. And like I said, I'm a little bit surprised that it worked as easily as it did. But we're going to use it until it breaks. And the first thing we want to do, now what I want to do is, I hate this. I hate pretty much all of this. For each button press, we are checking, is it the key, or we should do some bookkeeping here. I'm gonna hold that thought, or I hold that thought, and we're gonna update here the keys. We're gonna do EQ key up is 0x41, down is 42, whatever right is 43, and left is 44. So let's, what is for, this is left, key left, 43 is key right. X41, this is key up. I'm not even sure if you're not going to delete that at the end. Key down. Let's check it real fast. And it's still working, but it's all the computer is too hot right now. 32. Maybe I have to have a charging session. Okay. Control down, control something. We want to do, so we have the numbers. So we have 3, 4, 1, and 2. We're going to extract them. And now we're going to create a table. And we're going to look up in the table. Okay, we're going back to the hold that thought moment. We're going to first explain what we're doing here. Here at the moment, we are grabbing the input key via the syscall. We are also making sure we're not making sure at the moment it is really an input key. But we are grabbing that key or that number. It's one of the 40s. And then we're going to compare. Is this 41? Is it 42? Is it 43? And then go down the chain. And once we have done that, we have to actually also check in what direction does the thing move. Maybe we do that real fast. So, because at the moment, I can still go backwards, right? And this is not allowed in the snake game. We would just run into ourselves. And that's extremely bad also if you want to do the fast turnarounds. Now at the moment here nothing is fast. So, but we have another comparison here to do if we are honest. We would have compare AL, compare 1 second. So if we are forward, we would have to compare byte. If we are going backwards in direction 4, we could not go. We have to compare 4 with direction rip, and then say jump equal to end controls. This should be allowed. Yeah. x86 allows a lot. So this would be 4. Here we would check with the 3. Here we would compare up is 1, so with the 2. And here we would compare with the 1, I hope. So let's try that. We are crawling. So now I cannot turn around. Let me see if we can at least, maybe we can trick him. Right now I cannot turn around, neither in this direction. If I go up and press down, it still moves down. And if I go down and press up, I can't go up. Okay, computer glitching. Nevertheless, I mean, he has a reason right now. First of all, it's hot. And this one had a problem with overheating. And now, we are here, we are doing all of this just to decide which key was pressed and is the direction allowed, or should we update the direction? This is horrible. So we are going to change that right about now. So how do we change it? Now we're going to create a lookup table, and we're going to, we have basically 4 integers, 1, 2, 3, and 4, and we're going to say if up was pressed, we get the 41, we extract the 40, we have a 1, and that's going to be the direction, unless we're looking up in a table what is the forbidden direction, which would be the 2, and if the value in that table is equivalent to the current direction, then we're going to bail out. Okay, that's the goal. So how do we do that? We're going to create a control snake reverse lookup table. That's all, and then we're going to make it byte white. Byte 0 has a 0 because our 4 values start of 1, 2, 3, and 4, and on the position 0 of the offset is nothing. On the first byte, so this is, if you have the direction 1, you would go to this position and ask what is the forbidden direction. This would be the 2. And then we're going to go to the second, this is like 0, 1, 2, the second, and the forbidden direction would be 1. Then we are at 0, 1, 2, 3, the forbidden direction is 4, and on 4 the forbidden direction is 3. So 4, direction 1, direction 2 is forbidden. So do this. We're gonna do this for direction 2. 1 is forbidden. And remember, this is the offset that we are looking at here, because we're going to use the value immediately with the table address. So this is replace 3, 1, this is replace 2, this is replace 4, and where are we? Jack this, and battery here is fine. I think the laptop is gonna give in first today. So 3 replace 4, F4 replace 3. So these are the offsets, and now let us get this value. Control snake. I'm gonna go wherever. What is this here? This is our, oh yeah, but why the input keys work this way is still a little sus. So let's, oh no. So get this, and we need the address. And I have no idea what we have at the moment, so we're going to use, I don't know, layer queue. Well, here we're going to use rip RC. Why not? Let's put it in RC. We have the RSE key, and I don't trust this here at all now. I'm gonna XOR Q RAX. Yes, RAX, because we're gonna read in the input key in RL, and now we're gonna subtract byte 0x40 from a low. Now we should have only the last digit. No, we will have only the last digit of the input key. And whatever. Once we have the last digit, we're going to use that now to get the forbidden direction. So move Q RSE, use the RAX. That's why I zeroed it out. Maybe there's something in the front part of 1 into RCX. I mean, we have to check the registers in a moment, but for now let's assume we can place it in RCX, and now we still have to load the direction. So we're gonna move, can I write? Move Q direction rip into RDX. No, we're gonna have here definitely gonna use D low, and RCX is also move byte in C low, and I know struggling. SEL is for RSE low. Maybe we don't need it. So now we have the direction, the current direction, and the forbidden direction in CL. We're going to compare bytes CL with DL, and if they are equal, jump equal and controls. Still 1L. Okay? And if they are not equal, now remember we have in CL already the correct value because we are using the second digit from the input keys for our direction, so we can just move byte CL into direction rep. This should be fine. And that would mean that all of this becomes obsolete. Why did you not do anything? GV, insert this. Thank you. So let me copy. Is he doing anything? That wall is moving, but we have a value error here. Our left and right is wrong. Oh, I know. I think I know. Yeah, 1 second. We have the key value, so if I press 1, the forbidden direction is 2. Now this is correct, right? Now this seems actually fine. So there is something wrong with stopping. Let me where is the, let me comment that out here for a second. Cannot run. You are taking battery life from us. I take out the control snake. Okay, that still works. Okay. What which direction is wrong? What is wrong here? So we get the input key here. We subtract 40. Well, let's, can we move through that direction? Is the CL, wait, why is this an AL and what is CL? We move byte into CL, that's the forbidden. Now we have to move AL into, AL is the key value, CL is the forbidden direction. Permission denied. So this I cannot return, but the start is somehow not correct. So this I cannot turn around, I cannot turn up, cannot turn left, I cannot turn right, and now I cannot turn left. So it works, but it doesn't work. Why doesn't it work at the beginning? That's the weird part. I mean, anyways, we should check. We should have two syscalls. That's a completely different topic. But I think we're gonna go to raw mode. What is the battery saying here? I can't read it even. 24? Oh, this is like bastante. So, let's turn off here the Vmin and V time to 1. So we are now again blocking. Let me check the camera as well. Okay. So we're now again in blocking mode, but we need that to debug it. So LLDB snake. First of all, we need to know what we debug. Debug snake. And where is control snake? Break set minus address. Yep. Step. Push, push, push. Input key. Copy x3064 maybe 64 XP. This here. So I think I know. No, I don't know. $46. What is the 46 there? Where is the direction? 1 second. This is not correct here, huh? Register read RSE. This is the input key. We need this x64xp. Yeah, here and there are like, I was like, what the hell is this? So here are our 4 Z characters. Step, 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 syscall. It didn't ask me for a syscall. We changed that. Did we write it? We wrote this. But it should ask. LLDB, snake, break. run it. 1 second. Are we off now? Oh no. Okay. Okay, we have to do this. Break. So control snake, go here, 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 control R. Here's the input key, syscall. Now I can press, I press up. Okay. And now we have here only, it's a weird moment though. So now we have only the 0x1b. That is why I was so surprised that it was working, because the moment we have vmin to 0, we normally only get 1 byte. And that's the escape. But something is still a little surprising. But it's not expected. So we should first get a read of 1 byte. And once we have checked that it's actually an escape, then we're going to do another syscall with 2 bytes, and then we're going to get the number. Actually glad that we are there, because that is a little surprising. So let's go to our control snake function and let's implement that. That's very easy because we have everything already done. So where are we? Here's the syscall. We get the key, and well, first of all, now we're going to check move byte of input key in rip into RAL, and then we're gonna check. Well, we're now taking the 0th byte, and we're gonna say compare with 0x1b with RL. Compare byte, and if they are not equal, jump not equal and control whatever we called it, input. Yeah, J. So let me check what we called this here, and control simply. So now this is also good because we are checking if we press anything else except for escape. Well, at the very end we're going to take care of escape itself. Then we're going to keep on moving, branch and control. Otherwise, we're going to do another syscall, and now I'm actually going to copy this. But now we're going to call this for 2 bytes. Actually, let's do this here, and let's reduce this to 1 byte. Now we're going to do 2 bytes, and now we're going to get the 05B or something and the 40. This is like a 2 byte number, and we want the second byte. So 01, this is the second byte now in AL, and if everything is correct, now in AL should be the 0x40. So we can step through that in a moment. One thing I want to say, now I stopped here with the 4 characters, so let's, why can I not go FZ, XX, okay. Let's compile it. End control referenced, undefined symbol, end control. Do you give me a line number? You do not. Do you? No line number? And this is really on. I think it's end controls. You happy? You happy. So this. Do we have raw mode activated? Do we want to test it, or do we want to step through it? Well, let's test it, and if it doesn't work, are we going to step through it either way? So let's do that. Let's run it. We're going to take care of the function. Okay, I can move up, I can move right, I can move left, I can move down, I cannot return in this direction, I cannot turn down, and I cannot turn up. And now it's going to pick up steam here. Okay, so this is working. Let's step through it anyways. And before we do that, we're going to do one thing. We're going to get rid of this nonsense. Because I really, really did not like this. There's beginner friendly, and then there's horrible. This is horrible. So this is good. Have I now set this to 1? Yeah? 1. Almost. 1. Next. Where is our chop the tail off? No, we're not. So raw. 0 something. Did I delete it? Where is the raw mode? Raw mode. Oh no, and we have here 1. So we are in blocking mode. Okay, we are almost done. Let me check everything. What's the battery status? Come on, we can do this. What is it? I don't see it. 18%. Yeah, that's okay. We are almost done. So LLDB. No. Oh yes, LLDB snake. Control break. So we have our breakpoint with 66 or something, right? This one. I think. Come on. Don't be so weird. Bad, what? No, don't do that to me. We didn't do anything. If I deleted something you didn't like, I'm taking it back. Did I delete end controls? No. Where are you struggling, my friend? LLDB, snake. You know what? Object dump MSD snake. Let's look if this is really indeed still this thing. Control snake. Actually, we want to go here. So let's go there. LLDB snake break set news A. He cooled down a little bit apparently. It's like crazy that you can feel that. Okay. Run it. Control snake. So do our function stuff. Now we do the first syscall. There is our. I now reduced it to 2 characters. Here's 7A, 7A. And now we're going to do the syscall. I'm going to press up. And now we just read in 1 byte. So here is 0x1b, or 1b in hex. Now we're going to compare that. Now we're going to move that into a low. Register read a low. So there it is. Where are we now? Frame select. Oh, it was there. I just can't read it here. So now we're going to compare it with 1b. As it is 1b, we're going to keep on moving. We're going to load everything again for the syscall. I'm going to press the syscall. Nothing happened. And we're going to read in, and here are now the other two characters, 5b and 41. We are only interested in the 41. And now let me check here RAX, register read RAX. RAX has nothing because I'm deleting it. Maybe that's not necessary. Nevertheless, now we should get the 41 in RAX, register read RAX, register read RAX. There's our 41. We subtract 40, so now there's the 1. And now we're going to get our table, register read RSE, register read RSE. Yeah, that's the address of the table, so let's go to the table. We have a 1, so 0, 1, and the 1 position is a 2, so the forbidden direction is a 2. So now by loading this into RSE, register read RSE, we should get the 2 here. We get the 2. Do we get the 2? No, we don't get the 2. Why is this working? We want yeah, this is completely, that's not completely wrong, it's just wrong. Because what we want, obviously, is the byte at that position. So we want, no, we want the address. I'm lying. All is good. So we have the, I'm just too far ahead. That's okay. I don't know if this is also. So now we have the address of the table. Register read RAX is, register read RAX is 1. RSE is the table. And now in CL, that's where we want the forbidden direction. Step, register read RCX, register read RCX. Did we do it? Register read C low, register read C low. There's a 2. Okay, that's fine. We have our 2 because we are only comparing C low here. Register read D low is a 3. So I pressed up, but we are moving in the forwards direction, so it's fine. Jump equal ends control. We're not going to the uncontrol, and now register read RAX, register read low is the 1, and now we're going to store that in the direction, and from there on the control function is finished and says we updated the address. So that's all good. So we step through it. There's one last thing that we're going to do now, which is pretty much the same. But first of all, we're going to restore the raw mode so we can control our snake. So where are the zeros? Here are the zeros. Let's test it. Even though that's battery intensive, we can move it and we can't return. And now it's cooling down so we get reasonable speed. Okay, so one last thing. The same thing we're going to do here. This is the exact same workings as a switch table. So we're going to use a switch table right now for our move snake function. We're just going to substitute that. It's the exact same thing, and it is just a little cleaner. So, exact same spiel. Here we have move forward, move backwards, move up, move down, and now we're going to create here a move snake switch table. Now this is going to fill with labels, and what the default is 0 for now. And now we have to be careful that I get the right one. 1 is move up, I'm going to place the move up label here. In 0, 1, 2 is move down. Move 3 is forward. And the last one is backwards. Okay, so now we have a switch table. Snakke. Move snakke. Gonna go here somewhere before we do all of this nonsense. So here we get the direction. The direction is a value 1, 2, 3, or 4. So now we also load our, what the hell is this, 340? Oh no, this is, I don't know if we pasted something. Okay. Okay, I'm in normal mode. Mark A, go here, jack in words, and go back to my label. Thank you. So move snake switch table. We're gonna get the address of that. Layer queue rip in RSE. I don't know why RSE. I hope right now that RSE is free. So we have the switch table in RSE, and now we're gonna move into RAX. We're gonna use our RSE table. We're gonna use the direction which is in RLow. So I hope RAX is free. So we're gonna use RAX, and now we have to scale it by 8 because the labels have word size for 64-bit, and we're gonna scale it by 8. So this now means we're gonna go here 0 times 8, 1 times 8, 2 times 8, 3 times 8, 4 times 8. 4 times 8, and we are getting the move backwards label into whatever, RAX. No, RAX, RCX. Okay? So now we have the label, and now all we need to do is jump to that label. And that's done with the star thingy here. So I think jump star RCX. So this means go to this label, and if that is the case, we can comment this out. Please don't die now. We're going to comment this out. We're going to comment this out. All of this, all the comparison is unnecessary because we are using the value that from the direction to jump immediately to the label. That's the idea, hopefully. So let's run it and debug it. Snake. Segmentation fault. All right. I mean, we had a little too smooth of a writing. So what is it? Well, we're not gonna waste our time. Don't waste your time on me. You already the voice inside my head. Register read RSE. Maybe we used the register we shouldn't have used. Switch table, register read RAX. RAX is not correct. So we are gonna simply XOR Q, XOR Q, RAX, RAX. Zero it out. Run it. Please come out. Still segmentation fault. LLDB snake. Run it. Register with RAX. Move snake. Oh, wrong part here. My bad. And there we are. And we are fast as hell. Okay, wait. Wait. Cannot. Stop it. We're gonna change here the value. So on the x86, this makes a difference. Okay, I don't know. Let's just, doesn't really matter. So let's run it. Well, no. After that, speed cannot go in this. So what was it before? 1, 4 maybe. 6. Boy, we had a weird glitch. We have a glitch. What's going on here now? Okay, now we're not finished. Job not finished. Where move snake. RSE RDX jump to RCX. Forward is 3, 0, 1, 2, 3, yes. We're jumping to 4. If it's 3, we're jumping to forward and direction. And directions all good. So we are still not correct here. Although RAX is for scaling and RCX. We have a label. RSE is definitely the address. That's the RAX. Is this not the label? Wait. So don't do this to me here with 18% battery life. We are gonna change this again. Object dump minus the snake. It's in control snake. Go here. LLDB snake rig set minus a here. We're back here. Gonna go syscall. It didn't ask me, or I was too quick. So I'm gonna go syscall up. It's an escape sequence. Second syscall. Now there's the 41. Register read RAX. Has a 2, this doesn't matter. Now it's 0. Now in low, register read RAX. That's the 41. That's good. Subtract the 40. Still a 1. Register read RSE is the control snake reverse. Oh, that's not correct. Control snake. What? Battery low. Yeah, we know that. Shut up. Few more minutes. Keep on moving. Move snake. Wait a second. Am I in the wrong function? I'm in the control function. Careful now. We want to be here in the move function. So why am I even? Why even do that? Okay, raw 1 raw 1. Why don't I find it this way? I'm not understanding this. Oh, because it's 16 and 17. It should even be easier. So this, put this back. Object dump minus the snake break. Give us the move snake LLDB snake break set minus address here. LLDB snake break set minus address. This is a write. I'm overwriting something there. We're overwriting, but where? And what are we overwriting? So all of this is irrelevant to us. Oh, no. Next. Step. Over and screen buffer. XOR here seems to be correct. Register read RAX 0. Step register read RLOW. That's the 3, that's the forward, that's correct. Switch table, register read RSE. Here's our switch table. Okay. We are 3, so boom, register read RCX. Move forward, that is correct, and we jump to forward. And we add 1 byte and we jump to the end. That is all correct. This is not our problem. We are overriding something. Okay, let's I press the arrow key. Did I change something in Control Snake when I should have? When I was confused. This is Control Snake. Did we RAX, this XOR is here because of this. We gotta get the input key, but move snake. Move snake. It has to be this is here. Move the direction, that's okay. Move Q, this is a label, this has to be a move Q. RAX is okay. Move forward. Direction is fine. Move snake switch table is fine. That's the address of the table. And here we have the move forward. This is all fine. What is happening? We are starting at the top position. Oh yeah, this is not good. Move forwards, move backwards, byte. Do I do direction here? What if I do this? It's the up key. Up and down does the same now. Wait, something is up, down, forward, backwards is definitely correct. Let me go back. Let me comment this out for a moment. Now I'm not controlling it at all. Yeah, because I didn't have this in. Actually need them. No, okay, this is not here. The problem is not here. The problem is somewhere else. I did something that I shouldn't have done. Oh, that's bad. Direction. Move by. This is the initial direction. And the move forward function is, well, let's do this. This cannot be so much though. Let's comment out this one. So it's in the move function. The problem, I changed something here that I shouldn't have changed. But what? Did I delete something accidentally? Move here in REX. It seems like the update now we are storing REX here on the stack frame, so we can use it here, right? The tail gets removed, but the head gets not moved forward. That's pretty much the issue right now. So, right, if you look at this, the head is not moved forward. So the problem is here. And we are loading RAX, RCX, and RAX. Oh, maybe I overwrote one of those here. RBX, RCX. But I'm not even doing this right now. So what is in what was not in before? RX, RDE. Shit, what's the time here? That's, well, we have to step there. I want to go, okay, object dump minus the snake. Let's go to move snake, and after end directions, right about here. LLDB snake, break, set. No, go here. So register read step, register read RAX. What is here? Snake plus 6. This should be the head, I guess. Now we're gonna store RBX. 1 second here. RBX, register read RBX is 18. What? RBX, the new coordinate, and what is RCX? What was RCX? I think RCX is bad to be using, but we're not even using it right now. Nevertheless, all in on the table here. This is out. And now RCX, I'm gonna use R8 here for a moment. And A, we're gonna use 9. just so make sure we're not overriding there anything. LLDB snake, run it. Yeah, show us where. Oh my goodness. RSE low. R9 low. R9 below. I think it's R9 byte. Okay, but I can't control it. R9 byte, but it is something like that. So R9 is the direction. R9 byte. What is R8? Gets the thing. Add one to BL. Oh, did I wait? I turned off the control, so we are overriding there. We did an override of registers carelessly. So run, and I can move it again. Okay, so because the battery is low, and I think it's just a little bit slow, we're gonna end it right here. We're gonna change the 6 to a 1 for one more try. I'm gonna clean up the register the next time. We have a moving snake. That was the hardest part. I'm sorry for the mess here at the end, but now we have a switch table. It is just better. And next time we're gonna add the fruit, make the snow grow, and we are pretty much over the hump with the series. So thank you so much for enduring it, and thanks for watching. See you in the next one.